Hello students, this is the time to study now the first chapter of your physics, class 12. The name of first chapter in your book is Electrostatics. What is the meaning of electrostatics? You can easily understand the electrostatic is made by two words, electro and statics. Statics means for rest and electro for charge. So when the charge is at rest. So in this chapter we will study the cases or uh, points where the charge is at rest and we will study the charge. Now, the topic in this chapter will be number 1 frictional electricity, 2 properties of electric charges, Coulomb's law in vector form, units of charge, relative permittivity or dielectric constants, continuous charge distribution, linear charge density, surface charge density and volume charge density. So first topic is frictional electricity. So what is frictional electricity? Frictional electricity is the electricity produced by rubbing two suitable bodies and transfer of electrons from one body to other. So easily you can understand by the term frictional. What is the frictional? Rubbing between two bodies. So if two bodies are rubbed to each other, then electricity is produced and that electricity will be called frictional electricity. Now, for example, if we take a glass rod and rub it with a silk cloth, then silk will require negative charge and glass will acquire positive charge. Another example, if we take a ebonite rod, rub it with flannel, then flannel will become positive charge and an ebonite rod becomes negative. Now, what is the reason? Electrons in glass are loosely bound in it than the electrons in silk. Means silk में जो आपके electrons हैं that are mostly bound, strongly bound, and glass में electrons are loosely bound. So when glass and silk are rubbed together, the comparatively loose bound electrons from glass get transferred to the silk. तो glass में जो electrons loosely bound थे वो कहाँ चले गए? Silk में transfer हो गए. Now next. As a result, glass becomes positively charged and silk becomes negatively charged because all the negative charge transfer to the silk. That's why silk becomes negative charged. Similarly, in another case, ebonite. Electrons in fur are loosely bound in than the electrons in ebonite. So when ebonite and fur are rubbed together, the comparatively loosely bound electrons from fur gets transferred to the ebonite. So in first case, electrons was loosely bound in glass rod. In second case, electrons were loosely bound in flannel. So what happened? Where the electrons were loosely bound, they transferred from their place. In glass, electrons were loosely bound, so they transferred from glass to the silk. In second case, electrons were loosely bound in flannel, so they transferred to the ebonite. Next, as a result, ebonite becomes negative charge and the fur becomes positive charge. It is very important to note that electrification of body, whether positive or negative, is due to transfer of electrons from one body to another. Okay, means इलेक्ट्रिफिकेशन जो एक्वायर हुआ बॉडी में दैट इज ड्यू टू ट्रांसफर ऑफ इलेक्ट्रॉन फ्रॉम वन बॉडी टू अनदर. इन फर्स्ट केस इलेक्ट्रॉन्स ट्रांसफर्ड फ्रॉम glass rod to the silk. In second case, electrons were transformed from the fur to the ebonite rod. If electrons are transferred from a body, then the deficiency of electrons makes the positive body. Deficiency of electrons means lack of electrons. Obviously, you can easily say that in your lower classes that the atom which releases the electrons becomes positive. So in first case, glass rod releases electrons, so glass rod becomes positive. In second case, flannel releases the electrons, so fur becomes positive. If electrons are gained by body, then the excess of electrons makes the body negative. In first case, silk acquires negative charges, so it becomes negative. In second case, ebonite rod gets the electrons from the fur, so ebonite becomes negative. If two bodies from following list are rubbed, then the body appearing early in the list is positively charged, whereas the latter is negatively charged. Fur, glass, silk, human body, cotton, wood, sealing wax, amber, resin, sulfur, rubber, ebonite. These are the bodies which can be rubbed and produce frictional electricity. There is a table where the column 1 and column 2. In column 1, the objects will acquire positive charge if they will be rubbed with objects in column 2. Glass with silk, wool with amber, ebonite with polythene, dry hair and comb. So if you rub your dry hair to the comb, then your dry hair will be positive charge and comb will be the negative charged. Properties of charges. There exist only two types of charges, namely positive and negative. Like charges repel and unlike charges attract each other. Charge is a scalar quantity. Charge is additive in nature, means plus 2 coulomb plus 5 coulomb minus 3 coulomb is equal to 4 coulomb. Means if you added all the charges with their polarities, positive and negative, then you can add them as easily in your maths. Charge is quantized. What is the meaning of charge is quantized? Electric charge exists in discrete packets rather than in continuous amounts. So इसको आप ऐसे समझ सकते हैं दैट आप एक डार्क फैंटेसी का एक चॉकलेट बॉक्स लेके आते हैं, बिस्किट जो कुकीज़ बॉक्स है, वो चॉकलेट फैंटेसी पूरा आता है लेकिन उसके अंदर छोटे छोटे एनवेलप्स होते हैं और उनमें एक एक बिस्किट होता है, एक एक कुकीज़ होता है. तो उसी तरीके से चार्जेस भी क्वांटाइज्ड होते हैं. किसी भी बॉडी में चार्जेस पूरा स्प्रेड नहीं होते हैं, दे आर फॉर्म्ड इन स्मॉल पैकेट्स. It can be expressed in integer multiples. Fundamental electronic charge E is equal to 1.6 into 10 to the power minus 19 coulomb. You can easily say that this is the charge on the electron. Q is equal to plus minus NE. What is this meaning? Where N is the number 1, 2, 3. Okay? And E is the charge on the electron. N is the number of electrons and Q is the total charge. Let's again we come to Q is equal to plus minus NE. What is its meaning? Let you have two charges, plus 2 charge and minus 2 charge. Then what is the total charge of the body? Neutral. Similarly, if there are two bodies, one have 4 coulomb charge and second has minus 1 coulomb charge. So the total charge will be plus 3. Okay, you can easily add all the charges. So this will be charge is quantized. Next, charge is conserved. What is the meaning of charge is conserved? Means all the charges are conserved. Charge neither be created nor be destroyed. The algebraic sum of positive and negative charges in an isolated system remains constant. In an isolated system, total charges will be constant. When a glass rod is rubbed with silk, negative charge appears on the silk and an equal amount of positive charge appear on the glass rod. The net charge on glass silk system remains 0 before and after rubbing. Before rubbing, all the electrons were in glass rod. After rubbing, the electrons transformed from glass to the silk. But the total sum of the electrons and positive charges in these two bodies is 0 because neither charge be created nor be destroyed. Next, recently the existence of quarks of charge 1 by 3e and 2 by 3e has been postulated. If the quarks are detected in any experiment with concrete practical evidence, then the minimum value of quantum of charge will be either 1 by 3 or 2 by 3e. However, the law of quantization will hold good. So there is recently a theory, the existence of quarks of charge means एक charge इंटीग्रल मल्टीपल में ना होके quarks की फॉर्म में मिलेगा या तो 1/3 या 2/3. तो मिनिमम अगर आप charge की बात करेंगे तो it can be 1/3 or 2/3e. Now the first and very important topic of the chapter, electrostatics. Coulomb's law. Force between 2-point electric charges. What is the Coulomb's law? Coulomb's law explains the force. Coulomb's law defines the force between two charges. If there are two charges, plus q and minus q, then the force between them can be written, can be calculated by the help of Coulomb's law. And students, it is very important topic. You all have to know this law every time if you are a physics student. Okay, so be careful and attentive. So what is the definition of Coulomb's law? The electrostatic force of interaction between 2-point electric charges is directly proportional to the product of the charges, inversely proportional to square of the distance between them, and acts along the line joining the two charges. What is its meaning? Coulomb's law applies to stationary point charges. Let there is a charge q1, another charge is q2, and the distance between them is r. Then the force between these two charges will be directly proportional to the q1 q2 product. The force is directly proportional to the product of two charges. Which charges? q1 and q2. And similarly, the force will directly proportional to the inversely proportional to the square of distance between them. The force is inversely proportional to the square of distance between the two charges, or F proportional to the q1 q2 by r square, or F is equal to k q1 q2 by r square. What is this k? Proportionality constant. You all know. Where k is the positive constant of proportionality called electrostatic force constant or Coulomb constant. So k is the proportionality constant. And in this chapter, it has a special name, electrostatic force constant. What is k? Electrostatic force constant. So what is Coulomb's law? F is equal to k into q1 into q2 by r square. Remember, repeat with me. F is equal to k into q1 q2 by r square. So if you want to calculate the force between two charges, then what you have to do? Simply multiply the magnitude of charges q1 and q2, divide by the square of distance between them, and put the proportionality constant, electrostatic force constant, k there. In vacuum, k is 1 by 4 pi epsilon naught, where epsilon naught is the permittivity of free space. Epsilon naught is another constant and it is called permittivity of free space. So what you have to do? If you want to calculate the force between two charges, then just put the formula F is equal to k q1 q2 by r square. And at the place of k, you can put 1 by 4 pi epsilon naught. In medium, k is equal to 1 by 4 pi epsilon naught. In vacuum, it was 1 by 4 pi epsilon naught. In medium, it is k is equal to 1 by 4 pi epsilon, where epsilon is the absolute electric permittivity of dielectric medium. The dielectric constant or relative permittivity or specific inductive capacity or dielectric coefficient is given by k is equal to epsilon r is equal to epsilon by epsilon naught. So what is this meaning? What is this meaning? अभी हमने पढ़ा था what was epsilon naught? Epsilon naught was absolute electrical permittivity in vacuum. What is epsilon? Absolute electric permittivity in medium. So the ratio between them is k, capital K. This k is different from the former one because former one was the smaller k. It is the capital K is equal to epsilon r. What is epsilon r? Relative permittivity, because it is explaining the relation between the permittivity of free medium, vacuum and the medium. So epsilon r is equal to epsilon by epsilon naught. Therefore, in vacuum, F is equal to 1 by 4 pi epsilon naught q1 q2 by r square. In medium, F is equal to 1 by 4 pi epsilon naught r into q1 q2 by r square. Epsilon naught value is 8.8542 10 to power minus 12 c square coulomb square per Newton per meter square, and where 1 by 4 pi epsilon naught 8.9875 10 to power 9 Newton meter square per coulomb square. So आज के लिए स्टूडेंट्स इतना ही. आप लोग इसको रिवाइज कीजिए, बार बार सुनिए. थैंक यू.